Yes,
If
sir.
you see in this problem, tan inverse root 1 minus x by 1 plus x, can you see any substitution that can be done in this problem? Remember this formula, 1 minus cos 2 theta by 1 plus cos 2 theta is equal to tan square theta.
Yes, sir.
So you have to substitute this here, because this under root, it looks like 1 minus x by 1 plus x looks like 1 minus cos 2 theta by 1 plus cos 2 theta. So I say let x is equal to cos 2 theta. Okay. So that means what is dx d theta? Dx d theta is minus 2 sine 2 theta, right? That means
Yes.
what is your dx? What is your dx? Dx is minus 2 sine 2 theta d theta, right? This is your dx. So therefore, what should be I? I is integral tan inverse root 1 minus cos 2 theta by 1 plus cos 2 theta, and instead of dx you put here minus 2 sine theta, sine 2 theta in fact, d theta. So everything has now been changed to theta. Okay. So now we shall see integral tan inverse root 1 minus cos 2 theta is tan inverse root over of tan square theta. And you can take this 2 out also. In fact, you can take minus 2 out. There's minus 2 sine theta, you see there,
Yes, sir.
minus 2 you can take out, and here you only left is sine 2 theta d theta. So now this becomes minus twice integral tan inverse tan theta sine 2 theta d theta. That means minus 2 integral tan inverse of tan theta is simply theta, theta sine 2 theta d theta. Now how do you integrate theta sine 2 theta? This is a product of two functions, theta and sine 2 theta, algebraic and trigonometric function, right? So you integrate this by parts. So how do you integrate? First function, you take theta, second function sine 2 theta d theta minus integral of the derivative of the first function into the integral of the second function, and you integrate the whole thing, right?
Yes, sir.
Minus 2 into integration of sine 2 theta is minus cos, right? Integration of sine is minus cos, right? Integration
Yes, sir.
of cos is sine. So minus half theta cos 2 theta minus integral d theta of theta is 1, and again integral of sine 2 theta is half minus half cos 2 theta. So minus minus becomes plus. You take half outside, becomes cos 2 theta d theta, right? So this becomes minus 2 times minus half theta cos 2 theta, and integral cos 2 theta is half of sine theta. Half and half combined to become 1/4 sine 2 theta plus c. Okay, that's it. And you put back the value of theta. What have we put? We have put x is equal to cos 2 theta. Let's see. So note here x is equal to cos 2 theta. That means what should be sine 2 theta? Sine 2 theta should be root over of 1 minus cos square 2 theta. That means root over of 1 minus x square. And also, what is theta here? 2 theta is cos inverse x, right? And what is theta? Half cos inverse x, right? So let us put now these
Yes, sir.
values. Therefore, what is I?
Yes, sir.
Hence, I will be minus 2 times. You can multiply 2 throughout also. That will do a little later. You could have done there also, no problem. Now, so theta here is half of cos inverse x. We put the value of theta. Cos 2 theta is x, right? Plus 1/4. Sin 2 theta is root 1 minus x square plus constant of integration. Now you can multiply your 2 throughout. So minus minus becomes plus, and you multiply this, it becomes half x cos inverse x, right? Plus 1/4 root 1 minus x square plus a constant. Yes? Any question?
No, sir.
No, sir.
So that is what you do here. Okay. Let us move on to the next sum. Again, an IC problem. Sin inverse x by 1 minus x square to the power of 3 by 2 dx. Right? How do you integrate this? Okay, now in this problem, see that you have 1 minus x square in the denominator, right? So 1 minus x square, if it is there in the denominator, the first thing that comes to your mind here is that what if I put x is equal to cos theta? Or let's say what if I put x is equal to sin theta? Because I see a sin inverse on top, right?
Yes, sir.
So let x is equal to sin theta. Then what happens? In the denominator, you will get 1 minus sin square, which is cos square, right? So things are going to get a little easy if you put x is equal to cos sin theta. Let us put x is equal to sin theta. So therefore, what is dx d theta? Cos theta. That means dx is cos theta d theta. So let us put these values. Sin inverse sin theta divided by root over of 1 minus, not root over, it is 1 minus x square to the power of 3 by 2. This becomes 1 minus sin square theta to the power of 3 by 2. And dx is cos theta d theta. So this is integral. Sin inverse sin theta is simply theta divided by cos square theta whole to the power of 3 by 2 into cos theta d theta. Okay. Now in the denominator, what happens? In the denominator, the square cancels with the 2 in the denominator of 3 by 2, right? So you only get a cos cube theta into cos theta d theta. So here what happens? One cos cancels. So what do you get? So what do you get here? You get theta by cos square theta d theta, which can also be written as theta sec square theta d theta. Now what to do? By parts. Take theta as the first function. You can integrate sec square. You can take sec square as your second function. So first function into the integral of the second minus integral of derivative of the first, put it in brackets, into the integral of the second, and you have to integrate this whole thing. So this becomes theta tan theta, because integral sec square theta is tan theta. This becomes theta tan theta minus integral d d theta of theta is 1. Integral sec square is simply tan. We get simply tan theta d theta. What you get here is theta tan theta, and integral tan theta is log sec theta plus constant of integration. Now you have to change everything to x again. So what have we substituted? Here x is equal to sin theta we have substituted earlier, right? So how to find out tan theta from
Yes, sir.
sin theta? Now you can find out cosec theta, right? Cosec theta will be 1 by
Yes, sir.
x, and you know that cosec square theta is 1 plus cot square theta.
Yes, sir.
So you can get cot from here, then you can find tan. That means from here cot square theta will be cosec square minus 1. So
Yes,
this
sir.
is 1 by x whole square
1 by
minus 1.
6
That means 1 minus x square by x square.
x
Okay,
square.
so
Yes, sir.
therefore what is cot theta? Cot theta is root over of 1 minus x square by x. That means tan theta is what?
Yes, sir.
Tan theta is x by root 1 minus x square.
Sir, it will be x square, no?
Now we are taking square root, no? That's why x square becomes x.
Okay, sir.
Okay, sir.
So therefore we have got tan theta. Now you have to find sec theta. How do you find sec theta from sin theta? You find cos theta, and then you can find sec theta. Cos theta is equal to root 1 minus sin square theta, and this is root 1 minus x square. That means what is sec theta? Sec theta is 1 by root 1 minus x square,
Root under.
which you can
Yes, sir.
also write as root over of 1 by 1 minus x square. Anyway, you can write. Now you can simply put the values here. Therefore, what is the value of I? Hence, I is equal to theta tan theta. Theta is, if x is equal to sin theta, you can write here also theta is equal to sin inverse x. Okay, so instead of theta, you put sin inverse x. Instead of tan theta, you put x by root 1 minus x square. So you can write here x by root 1 minus x square into sin inverse x. Okay, or x sin inverse x by root 1 minus x square, and then you can put the value of log sec. You can put the value of sec theta here. Sec theta here is root 1 by 1 minus x square plus constant of integration. And then you can simplify this a little further also. You can write this as x sin inverse x by root 1 minus x square. And this square root, what you can do is you can take half log 1 by 1 minus x square plus c. And now what you can do here is x sin inverse x by root 1 minus x square minus half, can write this as log 1 minus x square, right, plus a constant. Next what you can
Yes.
do here is and write this as x sin inverse x by root 1 minus x square minus half of 0 minus log 1 is 0, right?
Yes, sir.
0 minus log 1 minus x square plus c. And finally, you can write this as x sin inverse x by root 1 minus x square. Minus minus become plus half log 1 minus x square plus a constant of integration. That's it.
Yes, sir.
Okay. So this is how you do this sum. Let us move on to the next sum. Now by parts is very important. One or two sums will definitely come from by part. Definitely one sum will come. At most two sums can come from by parts. Okay. Um, Next, what we want to do here is um, integral. Let I is equal to integral sine inverse root over of a by x by a plus x. Now this is very similar, okay, to sine inverse. We had done a problem on sine inverse. This is very similar to sine inverse, except that let me just give you an idea, and then you complete it on your own. Important sum, so please don't forget to do this sum. Okay, so
Okay, sir.
I'll just give you an idea of this sum. See that I have x and a plus x in the denominator. I also have a sine inverse. That means if this entire expression under the radical, if I can express this entire expression under the radical, if I can express this as a sine, then it will become our task will become a little easy, isn't it? Because sine inverse sine of something will give us our sine of something will give us our only theta, isn't it? If we can express this
Yes, sir.
as sine inverse of sine theta, then this will simply become theta. So that is what
Yes, sir.
we'll be trying to do. And how to make x by 1 a plus x as sine square theta? How to make it? Any idea?
Mm,
You see a plus x in the denominator, right? So straightforwardly, what
yes.
comes to your mind is if I put x is equal to a tan square theta. If I put x is
8
equal to
and
a
square
tan
theta.
square theta, then see what happens. Then see what happens. We get
Mm,
dx d theta. This is dx here, and dx d theta becomes, if you differentiate this, a is a constant, so 2a tan theta into dd theta of tan theta is sec square theta, right? That means dx is 2a tan theta sec square theta d theta. Now you put it,
yes, sir. Yes, sir. Yes.
therefore I becomes integral sine inverse root over of a tan square theta by a plus a tan square theta. And instead of dx, you put the value of dx in terms of theta. It is 2a tan theta sec square theta d theta, right? So now let's see what happens. Let us simplify this. Integral sine inverse root over of this becomes a tan square theta, and this becomes a into 1 plus tan square theta, okay, into 2a tan theta sec square theta d theta. Okay. Now see, 2a is a constant. You can take it out of the integration also. Let us take 2a out. Sine inverse root over of, now for sec square theta you know is 1 plus tan square theta. So in the denominator you can put this as a sec square theta, right? And this is tan theta sec square theta d theta. Okay, this is 2a integral. Now what about this? If you change, see this a and this a cancels here under the radical, and if you change tan square to sine square by cos square, right? And if you change sec square to 1 by cos square into tan theta sec square theta d theta, right? Now if you change, what happens?
Yes, sir.
This cos square, it cancels. So you're only left with 2a integral sine inverse root sine square theta. into tan theta into sec square theta d theta, right? So this is 2a integral sine inverse sine theta tan theta sec square theta d theta. So now what happens? Sine inverse sine theta is simply theta, theta
Yes, sir.
tan theta sec square theta.
6 12
Okay, theta tan theta sec square theta.
6 12 theta, sir.
Okay, d theta.
Yes, sir.
Okay, and then how do I evaluate this?
Yes, sir.
How do I evaluate this? Now again put t is equal to tan theta, because you know that the derivative of tan theta is sec square theta. That means you get dt d theta is
Yes, sir.
sec square theta d theta.
Yes.
Yes, sir.
That means dt is this is dt is d theta will not be here. So dt is sec square theta d theta. Therefore, what does I become? I becomes integral. See, theta here is, if t is tan inverse x, therefore theta must be tan inverse t, right? So you put tan inverse t in place of theta. Okay, and tan theta we have taken as t, and sec square theta d theta, this part becomes your dt. So t tan inverse
Okay,
t
sir.
dt. So this becomes t tan inverse t dt. Now how do you evaluate this? By parts. Take t as the first function, take tan inverse as the second function. Let us finish this.
Yes, sir.
We
Yes.
have done most of the part. Let me do it in short. Okay, you can try it in your full. First function into the integral of the first function is tan
Second
inverse
function.
t.
Yes, sir.
First function is tan
Yes,
inverse
sir.
t into the integral of t, which is
Yes,
half t
sir.
square, minus integral of the derivative of tan inverse t, which is 1 by 1 plus t square, into the integral of t, which is half of t square dt, right?
Yes.
So this now becomes half t square tan inverse t minus half integral t square by 1 plus t square dt. So this becomes half t square tan inverse t. How do you integrate the second part? Put write the numerator as like the denominator. T square can be written as 1 plus t square minus 1 by 1 plus t square
Yes, sir. T square.
dt. Now this becomes half t square tan inverse t minus, now if we separate, this becomes what? 1 minus 1 by 1 plus t square integral
DT.
dt, right? So this becomes half t square tan inverse t minus half, it becomes integral dt minus integral dt by 1 plus t square, right? So this becomes half t square tan inverse t minus half, it becomes t minus, and what is the integral of dt by 1 plus t square? If you remember, it is tan inverse t, right? So
Yes,
now
sir.
you can open this half, you can give a constant of integration also, half t square tan inverse t minus half t plus half tan inverse t. Now you can put the value of t and you can evaluate plus c. What is t here we have taken? We have taken t is equal to tan theta. Put t is equal to tan theta, right? And you will get, put t is equal to tan theta here. You can do it.
Yes, sir.
Yes, sir.
So that's it. You do it on
Yes,
your
sir.
own. And then you
Yes,
have
sir.
to
Yes, sir.
not only t, but you also have to put back the value of theta also. Okay.
Okay.
Okay, sir.
So there are two substitutions that you will have to do. Okay. So let us do
Okay,
the
sir.
next problem, last problem for today. The problem here is that I is equal to integral x plus sine x divided by 1 plus cos x dx. Okay. Now see, in this problem, first of all, we need to simplify this a little. You know that 1 plus cos x is by multiple angle formula. You know that 1 plus cos x is what? 2 cos square x by 2, right? You know this?
Yes, sir.
And sine x can be broken up as 2 sine x by 2 cos x by 2 dx, right?
Yes,
Now
sir.
you can separate here. If you separate, you get x by 2 cos square x by 2, right? Plus integral 2 sine x by 2, the dx here, 2 sine x by 2 cos x by 2 divided by 2 cos square x by 2 dx, right?
Yes, sir.
So now what happens? You can take half out of this integral. What are you left with? X by cos square x by 2, which can be written as x sec square x by 2. Am I right or wrong?
Yes, sir.
Plus, and here
Yes, sir.
2 and 2 cancels, 1 cos cancels here. You simply get integral x sec square x by 2 dx, and you get here tan x by 2 dx, right? So now how to evaluate the first integral? The first integral can be done by parts, right? You take x as the first function, x integral sec square x by 2 dx minus integral of the derivative of the first, that is ddx of, put it within curly brackets, ddx of x into the integral of the second, sec square x by 2 dx, and whole thing dx, right? So this is your integral of x sec square x by 2. And what is the integral of tan x by 2? You know, integral of tan x by 2 is log sec x by 2. You know this, right?
Yes, sir.
Divided, not only this, but divided by a derivative of x by 2, which is half. And again here, integral sec square x by 2 is what? Tan x by 2 divided by a derivative of x by 2, which is half, minus integral of ddx of x is 1. And again, integral of sec square x by 2 is tan x by 2 divided by the derivative of x by 2, right?
Yes, sir.
Plus
Yes, sir.
twice log
Yes.
sec x by 2, which is again half of 2x tan x by 2 minus, you can take, if you take this half, you can take 2 out of the integral. Okay, tan x by 2 dx plus twice log sec x by 2. So this is half of 2x tan x by 2 minus twice tan x by 2 again. The integral is log sec x by 2 divided by derivative of x by 2 plus twice log sec x by 2 plus a constant. Now 2 and 2 will cancel here. So what do you get? X tan x by 2 minus 2 log sec x by 2 plus plus twice log sec x by 2 plus c. Now if you see this and this cancel, we simply get x tan x by 2 plus c. That's it.